Today we're going to talk about graphing linear functions, section 2.3. Okay, let's think about it here. It says graphing linear functions. What's the root word in linear? Lines. So what are we graphing today?
Lines.
We're graphing lines. Okay, so we're going to graph some linear functions graphing lines today. So first off, vocabulary here. First thing is linear function. Again, what's the root word in linear? Line. So linear function is a line. It's a graph. Its graph is a line. Okay, something like that right there. That's a linear function. Slope, we talked about it in the warm-up here. Slope, it's a measure of the steepness of a line. You have to know the slope formula. y2 minus y1 over x2 minus x1. Must know the slope formula. That is a big deal. Okay. Again, here's an example of that with some coordinates. Again, slope is a number. A lot of times it could be a fraction, but slope is a number, not a coordinate. Slope is a number. All right? So it's y2 minus y1 over x2 minus x1. You get the slope. Y-intercept. Y-intercept is the y-coordinate of the point where a graph intersects the y-axis. So if I have a grid over here, oops, drop better one. Okay, if I have a coordinate plane over there, my y-intercept is where it intersects the y-axis. So it's something like right there. All right, that's going to be my y-intercept. Again, it's where the line crosses the y-axis. Y-intercept, y-axis. Next is x-intercept. Well, if the y-intercept crosses the y-axis, the x-intercept crosses the x-axis. So if I have the same line here, well, my x-intercept is the point where it crosses the x-axis now. Alright, so good note to watch that. And last thing we're going to talk about today is slope-intercept form. Slope-intercept form is by far the easiest form to graph, typically the most common way to graph as well. Slope-intercept form of a linear equation is y equals mx plus b. You'll want to know that formula right there, where m is the slope and b is the y-intercept. So in this equation right here, the 4 is my y-intercept, and the negative 2 or negative 2 over 1, that is my slope. Alright? Do you guys all remember seeing slope-intercept form from Algebra 1? We've done a lot of that in Algebra 1. Okay. Alright, first thing we're going to talk about is, well, what makes a linear function? It says, tell whether each set of ordered pairs satisfies a linear function. What's the root word in linear function?
Line.
Line. Okay. In order for it to be a line, that means it's got to have like a stair step, as in it goes up at the same amount. It goes up and over at the same amount here, okay? So in order for it to check, or in order for us to check whether it's a linear function, I'm just going to look at the change in my y's and the change in my x's. For instance, what's the change in my y's right there? From 4 to 3, what am I doing?
Subtract 1.
Okay, from 3 to 2. Subtract 1. From 2 to 1.
Subtract 1.
Okay, I'm subtracting 1 on all those, right? Well, let's look at the x's. From 2 to 5, what's the change?
Increases 3.
5 to 8.
Same.
8 to 11.
Same part 3.
Now, as I look at this, are my x's changing at the same rate? Yes. Are my y's changing at the same rate?
Yes.
Yes. So is this a linear function? Yes, it is. Okay. That would have a slope of, let's like, negative 1/3. That'd be my slope. Yes, sir.
What if it were like 3, 6, 9? Would that be a... No?
So let's look at 2 here. What's the change in my y's? 10 to 4, what's my change? 4 to 2. 2? 2 to 0? 2? Okay, let's check my x's now. Negative 10 to negative 5, I have 5. Negative 5 to 0, 5. 0 to 5, 5. So I'm looking at my x's. Are my x's good? Are my y's good? No. So is this a linear function?
No, sir.
No. What value would 10 have to be replaced with in order for that to be a linear function? 6. Yeah, 10 would have to be a 6 in order to be a linear function there, right?
Yep.
All right. Same idea. Now we have ordered pairs. Same idea here. Take a couple seconds to determine whether these satisfy a linear function or not. So if I were to look at number 3 of my x's, x's are plus 2, plus 2, plus 2, plus 2. Y's minus 1, minus 1, minus 1, minus 1. Is that a linear function? Yes or no, Allie? Yep, that's a linear function. All right, I can do the same thing on 4. 4's difference from x's is 2, 2, 2, 2. Okay, x's are looking good. Y's 12, 4. Well, now I'm adding 4. Well, now I'm adding 12. Is that a linear function? No. 4 actually makes a parabola. Right? But yeah, that'd be no.
Can't you just stop after you?
Did a couple of them?
Yeah.
All right, so that's linear functions. Pretty good. Next thing we're going to talk about is finding intercepts. Again, intercepts are where it crosses the x and the y axis. So you can use intercepts to sketch the graph. Again, x-intercept is where the graph crosses the x-axis. All right. Key here. It says to find the x-intercept, set y equal to 0. Well, why do I set y equal to 0? Let's look at the x-intercept down here. Here's an example of the x-intercept. What is my y-coordinate for my x-intercept? Anybody? What's my y-coordinate? If I look down here, what's the y-coordinate? 0. The y-coordinate is 0. Let's say I draw a line like this. Okay? What's my y-coordinate there still going to be? 0. What's my y-coordinate always going to be for the x-intercept? Yeah, the y-coordinate's always going to be 0. So what do? Well, we plug 0 in. This is what I call the cover-up method. Okay, in order to find the x-intercept, guess what? I'm just going to cover up the y. Okay? In order to find the x-intercept, I just cover up the y and I solve. I have 3x equals 12. What's x going to equal? 4. So my coordinate is 4, 0. Well, now I'm going to do the y-intercept. Let's look at the y-intercept now. What's my x value for my y-intercept? The x value is 0. Is it always going to be 0? Yes. So to find my y-intercept, what am I going to cover up? I cover up the x. 6y equals 12. What's y going to equal? 2. Well, that gets me my y-intercept now, 0, 2. Now, the biggest mistake students make on something like this, when they want to find the intercepts, is they want to say that's the coordinate. So they're going to say, oh yeah, my answer is 4, 2. What's wrong with that? That's a coordinate, right? The intercepts are each a coordinate. So I should have 2 intercepts, okay, giving me 2 coordinates. I did not make them into 1. All right, that's kind of key there on that. So let's look at number 5 here. I want to find the intercepts and then graph it. So I'm going to start off by finding the x-intercept.
4.
In order to find the x-intercept, what am I going to cover up? Okay, I cover up the y. So I have 2x equals 8. What's my x-intercept? 4. What's it as a coordinate? 4 what? 4, 0. So I'm going to go on my coordinate plane. I'm going to plot 4, 0. Now I'm going to do the next one. I'm going to find the y-intercept. To find the y-intercept, what am I going to cover up? So I have negative 4y equals 8. What's my y-intercept? Negative 2. So what's my coordinate going to be? 0, negative 2. I plot my coordinate there. Now I can take my line. And there's my line. Again, the coordinates each are a point. Big key. Coordinates each are a point. 6. Negative 3x plus 4y equals negative 12. I want to find my x-intercept. Bell, if I want to find my x-intercept, what am I going to cover up? If I want to find the x-intercept, what value should I cover up? I'm going to cover up the y. So I cover up the y. What's my x-intercept going to be here, Kyle? For what? No, for what? 4, 0, right? It's a coordinate. So I plot 4, 0. Now I'm going to do the y-intercept. Bennis, in order to find the y-intercept, what am I going to cover up? Cover up the x. What's my y-intercept going to be? So what's my coordinate? 0, -3, right? So there's my y-coordinate. Take my line. Ooh, that's a bad one. There we go. And there's my line now. All right, again, key for the intercepts is the cover up. Cover up the x to find the y, cover up the y to find the x. Take a couple seconds, try these two on your own. All right, let's look at these here. So number 7. First off, I want to find the x-intercept. All right, so x-intercept here. To find the x-intercept, Hannah, what would I cover up?
X.
To find the x-intercept, I cover up the?
Oh, the Y.
The y. What's my x-intercept, Hannah?
3, 0.
3, 0. Great. To find the y-intercept, Katie, what do I cover up?
X.
So what's my y-intercept? 0, -1. Ooh, there we go. And then I draw my line. You should get something like that. 8. Now, 8, the y-intercept's pretty easy, right? What's the y-intercept, Jake King? The y-intercept? 4, right?
You get rid of the x and that's
0, 4. Because I cover up the x and I solve and I get y equals 4. See it? Okay. Now the x-intercept's a tough one. What do I have to actually do for that x? I have to... So yeah, the x-intercept, I would have to add the x to the other side technically. Which would give me y equals... Or y, sorry. Y plus x equals 4. Now if I cover up that y, what's my y-intercept? Or my x-intercept? 4. So my x-intercept is 4, 0. I plot my coordinates here. I get something like that. Again, notice that number 8 is kind of a different problem there with that x-intercept. All right, you still got to solve for x in that sense. Plug 0 in and then solve for x. All right? Next thing we're going to talk about here is slope-intercept form. Slope-intercept form. You use the slope and the y-intercept to graph a linear function. The key to slope-intercept form is to solve for y. All right, that is the big key for slope-intercept form. You always need to solve for y, as in you need to get y alone by itself. All right, so notice here I have 2y plus x equals 6. First step would be to subtract the x to the other side. The next step would be then to divide by 2. Doing that then gets my y all alone. Now, why do I want the y all alone? Because then I can identify my y-intercept and my slope. So my y-intercept would go on my graph. From my y-intercept, I use my slope, -1/2, down 1/2, down 1/2, down 1/2, and I continue that stair-step model, giving me my graph. All right, so that's the big thing there. So number 9 here, I want to graph y equals 3x minus 1. All right, am I solved for y already?
Yeah.
Yes, okay. So I want to start off with finding my y-intercept then. So in this equation, what is my y-intercept? What's my y-intercept? Was it? My y-intercept. -1. We just got done doing this, right? If I find the y-intercept, don't I just cover up the x? It's my constant, right? My y-intercept's always the constant. So what's my y-intercept here? -1. So my y-intercept is 0, -1. I plot that coordinate, 0, -1. Next, I need to identify the slope. What's my slope going to be here? 3/1. Recognize, there's my slope. It's 3, but we always want to write it as a fraction because it's rise over run. So I put 3/1. So from my y-intercept now, I'm going to go up 3/1, up 3/1. And I'm going to put dots there. Or which other way can I go?
Down 3 left.
I can go down 3 left ones, same idea. And now I connect them, giving me my line.
It's already solved, but why did we do all that work or no? We just put the 1 and 3 and
Yeah, it's already solved for y. Yeah, that's kind of the key.
We had to show you guys one answer too.
Yes. You have to identify those parts. So 10.
Well, wouldn't we identifying it on the graph?
Yeah, but it's helpful to write it out just so you see it. Okay, 10. X plus y equals 2. Is this one solved for y? No. How would I solve for y on this one?
Subtract.
I'd subtract x to the other side. Did I subtract x on both sides? Give me y equals negative x plus 2. Now I want to identify this. So what's my y-intercept here, Jake O'Connor? My y-intercept's 2, right? So what would that be as a coordinate, Jake? 0, 2. So that's my y-intercept, 0, 2. Then I need to find my slope. Joe Daniels, what's my slope? Slope is negative 1, or as a fraction, that's negative 1 over 1. So what's negative slope kind of look like? Right away, you should think negative slope. What's your negative slope always going to be like? It's going which way?
Down.
Down. As I look left to right, it's going to go down. Negative slope should always be going down. So as I go for my y-intercept here, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. All right, giving me a negative slope. And now I can connect my dots. And now I get the equation at the line here. Again, right away, you should always recognize positive, negative slopes and think about what that should look like. All right? Take a couple seconds to try these two on your own now. All right, so number 11 here. First off, I need to solve for y, right? So how would I solve for y? Drew, what would I do first?
For number 11,
Yep.
you would subtract 3x from each side.
So I subtract 3x. That gives me negative 2y equals negative 3x plus 6. What would I do next then, Drew?
You would divide negative 2.
So I divide everything by negative 2. So that gives me the equation y equals. Now negative 3 over negative 2. Two negatives give me a. So I get positive 3 halves x. 6 over negative 2 gets me minus 3. Now I have my y-intercept.
Y is negative 3.
The y-intercept is negative 3, right? So what's that as the coordinate?
0, negative 3.
Now what's my slope?
3 over 2 or 1 and a half.
3 over 2. Always leave it note.
Oh, yeah.
Improper fractions. So I have 0, negative 3. From there, I'm going to go
Up 3 over 2.
up 3 over 2. So there's my dots. Connect them. There's my line. 12. 12, is it in slope-intercept form, Hannah? Is 12 in slope-intercept form already?
Sure,
Yeah, it is.
Sure.
Okay. So what's my y-intercept here going to be, Hannah?
0, 2.
Y-intercept 0, 2. Great. So I'm going to start at 0, 2. Hannah, what's my slope going to be?
Hold on. Try different.
It's
Oh, negative half.
Yep, my slope's negative 1/2 or negative 1 over 2. So negative slope, which way is negative slope going to go? It's going to go down. Again, I see negative slope, I'm saying it's going down. So from my coordinate, I'm going to go down 1 over 2, down 1 over 2. There's something like that. Connect my dots.
So,
And there's the equation of my line.
so you just do like, you only do the rise as negative?
What?
You only do rise as negative? Like, yeah. I don't know.
All right, last thing we're going to talk about today is when it comes up here, what happens if I have something like this? I have y equals negative 3. Let's think about this here.
That's where you put it. It's like straight. Y is literally negative 3.
We've been dealing with straight lines this whole time, but everybody does want to say that, yes.
It's like you put it over.
Okay, let's think about this here.
I don't know. I guess.
Y equals negative 3. What is that? That's technically my what?
Y.
That's my y-intercept. If it's y equals negative 3, that's my y-intercept. So I'm going to go to y equals negative 3. There's my y-intercept right there. That's like saying the coordinate 0, negative 3. Okay. Now, what type of line am I going to get there? Now, Kyle, he wants to say a straight line, yes, but what's the better term for that?
I forgot what it's called. I don't know what else.
A
Line.
Don't pay a pepperoni.
horizontal line. I'm going to get a horizontal line on an equation like that. This is a horizontal line. Okay, anything that's y equals is a horizontal line there. Why? Because all of these coordinates, if I look here, what is the y value of all of those coordinates right there? -3, right? All of my y values are -3. That's why it's a horizontal line through there. Now let's try this one. Is x equals 2. What is this? That's my what now? That's my x-intercept. Okay, so there's my x-intercept too. What type of line am I going to get now? I'm going to get a vertical line.
Horizontal.
That's going to give me a vertical line because now my coordinate's 2, 0. And now if you think about it here, all of these coordinates are where x equals 2. So that gives me a vertical line. All right, you have to be able to identify that. Horizontal line, vertical line. Have to be able to identify when you get those. All right? Here's your assignment.